Okay, welcome back. For task 2 of Lab 6, we want to create a second finite state machine controller that is based off of 4 states. We have the initial state, or the reset state, which we see the arrow coming from nowhere, is set up as off released. Our output, L, is off, and neither button or toggle switch is pressed. So it is released. As long as A and B are off, then we will stay in the off release state. If A is asserted, we will move into the on press state. The button has been pressed. L is equal to 1. Our output L is equal to 1, and it is on. As long as A is continued to be asserted, we'll stay in that state. If A is released, we move into the on release state. Our output L stays on, but the button itself is released. Pressing A again transitions to the off pressed state. The button is pressed, but our output L is equal to 0 or off. Again, releasing A, we move back to our initial state, our release state, where our output is equal to 0. Opening up Quartus and downloading our files, we have our .v file for our combinational logic. This is where we want to start. And so after we've downloaded it, we can open up. We see that we have our inputs called state, our outputs called next state, and L, right? I've started the state table for you. You need to complete it. Notice here that I've listed all of the combinations for off released. Going back to our finite state machine, all we have to do is list all of the transitions on our finite state machine into the table. So just complete that, and then you will have all of your state table. Okay. Once you have all of that, you can go ahead and actually create a symbol. There are several ways to create a symbol. I recommend that you come up to the File button and use the Create Update, okay? And you can actually create a symbol. Here, create symbol files for current file. So that would allow you to create the symbol. Once you've created the symbol, you can create a BDF file. Remember how to do a BDF. Come down here to New and collect and assert or push the block diagram schematic file. Okay, saving that as your toggle button fsm.bdf. You'll have two symbols. This was the symbol you just created for your toggle button combination. And then you also have to create a symbol for your state register. We can figure out how wide our state register needs to be using the ceiling function of log to the base 2 of the number of states. We know that we have 4 states, so therefore we can create a state register symbol as well. Just go ahead and create another BDF, calling it state register. We know that we need 2 flip-flops, so we have our state register here. We have our input port, next state. We have our output port, state, and we have our clock. Create a symbol for that, and you can either come over here and click on it, right click, or you can come up to File as I showed earlier. So we have our state register symbol, and we have our combinational logic symbol. We want to have our input ports, A and B. We want to have our and clock, and we want to have our output ports, L and state 1. Okay, and so this will be basically your top level design. We know that we can come over here and actually set it as our top level. So once we've done that, that should allow us to go ahead and run our test procedures. Some students have had a hard time with their test procedures. Some of the things that you might want to check: going under assignments and settings. If for some reason your model sim does not come on, you want to make certain 3 things. bringing up the settings and going to simulation, you should have this screen. Make certain that this format for output netlist is set to Verilog HDL. Several of you have had it set as VHDL. Set that to Verilog HDL. Okay. Also, make sure that you have a test bench listed here. If not, you can come and create a test bench. Click on the test bench, and you can click on New. Okay. Give it the name. You can give it. This one can have the name Toggle Button Finite State Machine Test, just like this, as the name, and then the same name for the file. If I go back to New, you can type that in there. The top level should come up for you. Okay, once you've done that, you're going to come down here and you're going to scroll for the FSM_test.vt. That is your test bench file. So do these things if you don't have anything listed. Okay, so once you've done that, I'm going to cancel this for now because I already have mine, and I'll cancel this because I already have everything set up. You should also have a script set up to run the simulation. Make certain that that is your .do file, your FSM_test.do. You can scroll through and find it if you're missing it. So that is what you should have for the simulation settings. And so if there's a problem there, just set those up as needed. All right, and so now we going back to our Quartus. We want to go ahead and run the compilation, and of course you should get errors for your model sim because you haven't added the equations. Once you've gotten it to actually compile with errors, then you can go back and write the equations. I recommend that you do it a little bit at a time to get it working a little bit at a time. You want to make sure that your states are working properly, okay? And so once you've done that, you can create a symbol from this finite state machine.fsm. Again, coming up here to File, go to Create an Update, and create a symbol for that current file. And so then you can open up a higher level. And so I have several higher levels. You can choose either the toggle switches. Okay, here I have the toggle switches. This is to use the switches that are toggle switch 9 and 8. Okay, notice I have my symbol, my toggle button FSM symbol that I have embedded into here. You should be able to find that under the symbol tools under project. So you will have your toggle button FSM there, just like you found your others. Okay, I have added the debouncing. The toggle switches can create some problems, so I've added the debouncing, and I have going into my finite state machine my debounce symbols. I've added the alternate out buffers into my outputs. I have my state 0 and my state 1 going into my out state or state outs. So we have that. Alternatively, you can use your push button switches. With your push button switches, we know they are low true, and so we want to add some inverters. So coming out of our debounce switches, we need to add some inverters. So here we have A0, and we have coming out of our A debounce circuit, and here we have our B0 coming out of our B debounce circuit. Now, don't try to run model sim for this level. Okay, once you've created these levels, you can go ahead and set this as the top level, or if you choose to use the toggle buttons, set that as your top level. And so then once you've done that, it will associate your QSF file, giving you the correct pin assignments. Okay, and so the other thing that you want to do is you can come up here to settings, right? And if you will remove the run gate level simulation automatically after compilation in this simulation, then you don't have to run model sim after you've gotten to the adding the switches, the actual physical switches. No need to run model sim for that. Okay, so that should do it for this task. Thanks for listening.